everyone. My name is Sakshi Guge. I am from Computer Engineering branch. Today I am going to talk about home automation using Arduino PicsimLab and Blynk IoT application project. During this project, we learn about C programming, embedded system, and IoT, which means Internet of Things. First of all, we will see from C programming fundamentals. Basically, C is considered as a middle level language because it supports the feature of both low level and high level language. There are some basic elements used to construct as a simple C program. First is the C character set, the identifiers and keywords, data types, constant, arrays, declaration, expression and statements. First we will see from the C character set. It is a consist of some character set, numbers and some special symbols that are given here. Identifiers are named given to various programs elements such as a variable, function and arrays. Identifiers consist of letters and digits. In any order, expect that the first character must be a letter. Both uppercase and lowercase letters are primited and the underscore may also be used as it also regarded as a letter. Keywords. Keywords are reserved words that have standard predefined meanings. These keywords can only be used for their intended purpose. They cannot be used as a programmer defined identifiers. Data types. A data type specifies the type of a data that a variable can store, such as an integer, floating character, etc. The data types supported in C are described below. Int, character, float, double, and void. A variable is nothing but a name given to a storage area that our programs can manipulate. Each variable in C has a specific type which determines the size and layout of the variable's memory. Arrays. An array is an identifier that refers to a collection of data items of that have the same name. A constant is an identifier whose value remains unchanged throughout the program. Integer constant. An integer constant is an integer value number. It consists of sequence of digits. Floating point constant. It's a base 10 or base 16 number that contains a decimal point or an exponent or both. Character constant. A character constant is a sequence of one or more characters enclosed in one apostrophe. Symbolic constant. A symbolic constant is a name that substitutes for a numeric constant, a character constant, or a string constant. This is a steps when we learn C. Now let's move towards the embedded system. An embedded system is a combination of a computer hardware and software designed for a specific function. Embedded system may also function within a large system. The system can be programmable or have a fixed functionality. An embedded system is a microcontroller or microprocessor based system which is designed to perform a specific task. For example, a fire alarm is an embedded system. It will sense only smoke. This is the characteristics of embedded system, in which the first is task specific, time specific, minimal user interface, high efficiency, high reliability, highly stable, low cost, and it requires less power. Now let's move to the structure of embedded system. First is hardware. The hardware of embedded system is based on around microprocessor and microcontrollers. Microprocessors are very similar to microcontrollers and typically referred to CPU, that is integrated with other basic computing components such as memory chips and digital signal process. Microcontrollers have those components built into one chip. Second is software. Software for embedded system can vary in complexity. However, industrial grade microcontrollers and embedded IoT systems usually run very simple software that requires little memory. Third is real-time operating system. These are not always included in embedded system, especially smaller scale system. RTOSES define how the system works by supervising the software and setting rules during the program execution. In the terms of hardware, a basic embedded system would consist of the following elements such as sensors, analog to digital converters, processors, digital to analog converters, and actuators. Now let's move towards the structure diagram of a system, embedded system. Then we see here the classification of embedded system. There are four types of classification here. First is mobile embedded system, means it is embedded in mobile phones and cameras, etc. Second is standalone embedded system. Standalone embedded system work by receiving the input without using any ghost system or desired outputs. Third is network embedded system. Network embedded systems are usually general purpose processors. Fourth is real-time embedded system. Real-time embedded systems are designed to perform a specific task within a time frame. This real-time embedded system further divided into two parts. First is hard real-time embedded system, which means the type of a system makes sure that all the critical processes are completed within the given time frame. This means that all the delays in the system are strictly time bound. Also, there is a little to no secondary memory, and data is stored in short-term memory or read-only memory. Second is soft real-time embedded system. These are much less constructive than the hard real-time embedded system, but the basic premises is the same. That is, critical process need to be completed within the given time frame. However, this time frame can be little flexible. Soft real-time systems are used in a various areas such as a multimedia, scientific projects, etc. In this embedded system, there is some main requirements of this. First is microprocessor, a computer processor where the data processing, logic, and control is included on a single integrated circuit or a small number of integrated circuits. Second is microcontroller. A microcontroller is embedded inside of a system to control a singular function in a device. Memory. Third is memory. There are two types of memory: static memory and dynamic memory. The primary difference between these that the lifetime of the data they store. Fourth is input and output interface that is used to as a method which helps in transferring of information between the internal storage devices such that memory and the external peripheral devices. Now let's move toward the Internet of Things, which means IoT. The Internet of Things is the concept of connecting any devices to the internet and to other connected devices. The IoT is a giant network of connected things and people, all of which collect and share data about the way they are used and about the environment around it. Over the past few years, IoT has become one of the most important technologies of 21st century. Now that we can connect everyday objects, kitchen appliances, cars, etc. to the internet via embedded devices, seamless communication is possible between people and processes and things. By means of low-cost computing, the cloud, big data, analytics, and mobile technologies, physical things can share and collect data within the minimal human intervention. In this hyper-connected world, digital system can record, monitor, and adjust each interaction between connected things. The physical world meets the digital world and they cooperate. Now you can see here this is the IoT architecture, and this is the seven layer of the IoT, in which the first layer is things, second layer is connectivity edge computing, third layer is global infrastructure, fourth layer is data injection, fifth layer is data analysis, sixth layer is application, and seventh layer is people and process. As they are seven different layers, they conduct seven different functions here. Now let's move toward our project requirements. In this project, we use microcontroller Atomiga 32P on Arduino Uno board. Coding platform is Arduino IDE. Internet connectivity for remote control is Blynk IOT application, which is on phone. Simulation deployed using PicsimLab. Here we can use virtual port, serial port, or null modem emulator for a serial communication. Guidance lights are LDR sensor, and temperature system is LM35 sensor, and water tank is serial communication protocol. Here we can see the PicsimLab, and here this is the null modem emulator. Now project solution. Control guidance lights on basis of sunlight intensity. Lesser the sunlight brightness, the guidance lights. Temperature system control switcher, heater and cooler on or off remotely. Switch heater off automatically if the temperature indoors exceeds 35 degrees Celsius. Water tank control, switch inlet and outlet valve on or off remotely. Switch inlet valve off automatically if volume of tank drops below 2000 liter. Guidance light ADC. Light dependent resistor used to sense sunlight and send analog signals to microcontroller. A microcontroller adjusts brightness of a guidance light with respect to analog signal sent. Analog to digital conversion used to read analog inputs. Only analog means A0 to A5 connected to the ADC block. ADC has three steps: sampling, quantization, encoding. Guidance PWM. PWM PWM, which means pulse width modulation. It is used to brighten up or dim LED with continuous change in sunlight. Analog output needed, not possible in digital system. PWM used to simulate analog output. Works on persistence of vision. LED switched on and off in quick session. Brightness can be controlled by controlling the amount of time the LED is on state in the one cycle of output signal. Temperature system. The temperature control system consists of heating resistor and LM35 temperature sensor and a cooler, which resembles the temperature control system at home. Read the temperature from the temperature sensor LM35 and display it on the CLCD. Control the temperature of the system by turning on or off the heater and cooler through the Blynk IoT mobile application. LM35 is an integrated analog temperature sensor whose electrical output is proportional to the degree centigrade. LM35 sensor does not require any external calibration or trimming to provide typical accuracies. Data streams are created on Blink dashboard templates. These act like a virtual pins for exchange data between mobile app and microcontroller. Now let's move to the water tank. The diagram is shown is the water tank. Here we use serial remote tank as a simulator. Virtual serial port used to set up serial communication between PicsimLab and serial tank. In real world, RDX pin of tank connected to the RDX pin of microcontroller. To control the inlet valve or outlet valve, send a byte either 0x00 or 0x01 respectively, followed by another byte 0x01 to enable or 0x00 to disable. Virtual pin V3 used for displaying volume on mobile app interface in gauge form. V4 V5 data streams used for transfer of data related on or off status of inlet and outlet valve. V7 pin is used to send notification to terminal on application corresponding widget created on developer mode in application. The microcontroller is so programmed as to turn off the inlet valve if the tank is filled up and turn on the inlet valve if the volume tank drops below 2000 liter automatically. It sends corresponding notification regarding these events on the Blynk IoT application. Real-time volume of water and on or off status of inlet and outlet valve is displayed on CLCD. This is a conclusion of our PPT. Here we use Blynk IoT application and PicsimLab simulator, simulated home automation, where LED temperature system serial tank resembles light, heater, cooler, and water tank in real time. CLCD acts like a dashboard used for displaying the events. Widgets from Blynk IoT application like a button widgets are used to control heater, cooler, and inlet valve, outlet valve. Gauge widgets to display the temperature and volume of the water. Thank you. Now let's move towards our project here. Here this is a PicsimLab. In this PicsimLab, we connect to the board Arduino Uno, which is from ATmega328P family. In this, we configure serial port COM1. After configure serial port COM1 in PicsimLab, we will go to the tools and select serial remote tank. From this, we configure to the serial port COM2. Now we can see the analog reading is 0. Slowly the water rises here. You can see the water start filling here. Now if on the certain limit it will rise. Here we set into 3000 liter. Now we can see on this on the CLCD dashboard the inflow of the water is started. It will rise till the water is full like 3000 liter. And we can see on the our mobile Blynk IoT application. This is a Blynk IoT application. This is a template of home automation that we created. After we clicking here, there will be two tabs, tab 1 and tab 2. In this tab 1, we created widgets button of cooler and heater, on and off button. And the temperature sensor is the gauge, which will show our temperature on mobile phone. And this is a CLCD. On this CLCD, we can also see the temperature value. This is a dashboard and this is also dashboard. Now we can see the notification bar. Here we will get notification of our project. This is a type 2. In this type, there is a inlet valve and outlet valve on and off button. This is water volume gauge. Here we can see the water volume is 3000 uh, because of this, because the water tank is full. So you can see the reading here. This is same reading from here. If we on the outlet valve, the water started decreasing. It will decrease on certain limit. If we cross 2000 limit, then the water tank started filling again. You can see here notification that water volume is less than 2000, so turning on the inlet valve. And you can see here the inlet valve is started. Now you can see the water is started filling. Again we will get notify here if the water get full. Wait a minute. Now you can see the notification here. The water tank is full, so turning off the inlet valve. And you can see the inlet valve is off. Now let's see the other function. If we on the cooler, we can see the fan is started rotating, and you can see the on the CLCD board that cooler is on. If we off the cooler, we will see on the dashboard that cooler is off. If we on the heater, we will see on the dashboard that heater is on, and on the certain temperature it will stop heating. We can see the notification here that the temperature is above 35, so turning off the heater, and automatically the heater will be off. Now let's see the guidance lights. It is dependent on the sensor where that if the brightness is high, the LED will be off. If the brightness is low, the LED turn on. Now we will see the code here. This is our project code. In this code, we created different files for different headers for easily access, and add these different files to the main code. You can see here include main.h, include system.h, include ldr.h, include serial.h. This is the code for cooler vpin. This is for heater vpin. This is for inlet valve and outlet valve. This From this we go to the compile, and we export compile binary and load into the PicsimLab using the load hex function, and we will get this. And here we connected every spare parts to the different properties like this. That's it for this project. Thank you for listening.